Question 21, we have a series of reaction steps: benzene to nitrobenzene to phenylamine and to N-phenylethanamine. Okay, which line in the table is correct for the types of reactions happening each step? So you just got to know your reaction types. Okay, so step 1, we've got benzene changing to nitrobenzene. Any benzene one you should know is going to be electrophilic substitution, which is what we definitely have here. This is nitronation, and you should know the full mechanism for that one as well. Okay, now we've changed NO2 to NH2. So what we've done is we have taken out oxygens and increased the hydrogens. So that is reduction. And then finally, we've created an amide link. If we look here, we've got NH, C double bond O, bond CH3. You should recognise that one from just proteins working stuff from higher. That is a condensation reaction, so C. Question 22. Carboxylic acids can be prepared in different ways. Which of the following is a suitable method for preparing carboxylic acid in one reaction? That's going to be important. Obviously, they've said one. Right, okay, so addition to an alkene. So can you get from this to that in one step? Nope. Okay, hydrolysis of a nitrile. Now this you actually should know, and that is a common reaction pathway to increase the length of a chain by creating this one here, so that is a single step. Reduction of an aldehyde, just to be clear, you've got your primary alcohol to aldehyde to carboxylic acid, which is a one step, but you should know this is an oxidation and this is an oxidation. So that's wrong for reduction. And substitution of a haloalkane, same deal. Could we get from, let's redraw that, sorry. Could we get from that to that in one step? And the answer is no. That's why it's B. Question 23. Student attempted to predict the mass spectrum of propanone. Predicted spectrum is shown below. The actual mass spectrum of propanone contains only 3 main peaks. Which of the above peaks would not appear in the actual mass spec? Okay, so we've got, let's be clear with propanone. So prop, double bond here, and we've got hydrogens on either side. So for a start, let's get the molecular mass of this one, because that's going to give us our kind of top peak. So add it all up. What have we got? So that is going to be 58. So this peak would definitely be here. Okay, and then you've basically just got to smash it up and see what would happen. So if I broke it here, I would get a methyl peak at 15. That's good. And my other side here would be 43. So that's good. This one is wrong, because that would involve you taking the methyl groups from both sides and then rejoining them. So not just kicking them out of the actual original molecule. So B, correct answer here. Question 24. Analysis of a compound shows the following percentage composition by mass. You've got carbon, hydrogen, oxygen, and empirical formula. Okay, so carbon, hydrogen, oxygen, 80%, 9.3%, and 10.7. Okay, divide by the relative atomic masses to get rid of the fact that they are different relative atomic masses. So that comes out at 6.67. This is 9.3 and 0.67. Okay, right, so we now need to get a ratio. Sorry, I shouldn't actually put a equals in here. To get my ratio, I'm going to divide by the smallest number. Which is going to give us something reasonably nice. This is pretty much 10, pretty much 14, and definitely 1. There you go. Okay, question 25. Which of the following splitting patterns would be observed for the circled atom in the high-res proton NMR spectrum of ethanol? Okay, so this hydrogen is the same as this hydrogen, okay? And this hydrogen environment is next to a carbon with 3 hydrogens next to it, okay? This hydrogen here is not going to interfere because it's got a break at the oxygen. So this one is going to make a quartet. 3 plus the 1 here, okay?